early effect. James early proposed it, so it is called early effect, and it is also called base width modulation. It is also called base width modulation. Let's assume we have PNP BJT. We have PNP BJT. So there is a emitter region, there is a base region, and there is a collector region. And in PNP BJT we have this junction is called emitter junction, and this junction is called a collector junction. And again, let's assume we have a BJT operated in active mode. So in active mode, collector junction is reverse bias. So in active mode, collector junction are reverse bias. And the reverse bias voltage is called VCB. Now, when BJT is operated in active mode, its collector junction is reverse bias through the application of VCB. Now, when reverse bias voltage is further increased, the depletion width at the collector junction increases. Now, since base region is lightly doped compared to collector region, in BJT, emitter region is highly doped, collector region is moderately doped, and base region is lightly doped. Since the base region is lightly doped, if we further increase the VCB, reverse bias voltage, then the collector junction region will extends more into the base region. And which leads to the decrease in effective base width. Now, this is the effective base width. Earlier, the base width was this. Now, the effective base width is now decreases. Let's say this is a WB dash. So, if we increases the VCB, the effective base width decreases and the base width become smaller. And this decrease in effective base width due to increase in VCB or reverse voltage of collector junction is called early effect or base width modulation. So we can say the base width modulation is the decrease in effective base width due to increase in reverse voltage VCB of collector junction. Now, the early effect or base width modulation has three consequences. The first consequence is alpha increases. Alpha is the large signal current gain of common emitter. Now, the explanation for this, if VCB increases, which leads to effective base width, which leads to the decrease in effective base width, and due to which number of recombination inside base region decreases, and if number of recombination inside base region decreases, means which leads to more carrier reaches to collector, and hence IPC will increases. Since we know that IPC is directly proportional, alpha is directly proportional to IPC. If IPC increases, means alpha increases. And we also know that beta is equal to alpha divided by 1 minus alpha. So there is a small increase in alpha will leads to large increase in beta. For example, if alpha value is 0.98, then beta will be 49. If alpha is 0.99, then beta will be 99. So we can say there is only 0.01 increment in alpha leads to there is approx 50 time there is an increase in beta from 49 to 99. Now the second consequence is emitter current increases. As we know, the emitter current is equal to IPE plus INE, and which is we can say is approx equal to IPE in case of PNP BJT. And we also know that IP is directly proportional to del P by del X. Now if VCB increases, effective base width decreases, and effective base width decreases means del X value decreases, and if del X decreases means the overall value of this function del P by del X increases, and hence IP increases, and which leads to the increment in emitter current. And the third consequence is punch throw may occur. Now if VCB is made sufficiently large, VCB is made sufficiently large, then we increases the VCB, further increases the VCB, then which leads to then the depletion region fully occupies the base region. If we increases the VCB sufficiently large, then the base region will be fully occupied by the depletion region, and which leads to the more number of current reaches to the collector region, and IPC value will increases. So we can say when we increases the VCB and in sufficiently large value, then effective base width will become approx 0, and there is a heavy current will flow through the transistor. There will be a heavy current will flow through the transistor, and which may damage the transistor. So generally we avoid punch throw so that to avoid the transistor to get damaged.